Hi there team, welcome to the third video on chapter 9, which is on constant acceleration. This is on constant acceleration formulae. This is the first of two videos that will cover this topic, and we'll get started. So just to kind of talk about what we're trying to achieve in these videos really, we're going to start generalizing to the point where we can calculate displacement, velocity or acceleration, and this is going to apply under conditions of constant acceleration. So the assumption we make at the very beginning is that acceleration is constant. That's a simplifying assumption to some extent, but it allows us to derive 5 key equations. Okay, so we're going to derive 5 different equations, 2 in this video and 3 will be in the next. And this set of equations that apply under constant acceleration are referred to as SUVAT or kinematic equations. Okay, where kinematic is a slightly old-fashioned term for them. You'll see them primarily referred to as SUVAT equations. Key thing here, and I'm going to say this a lot, is that we're applying the condition of constant acceleration. That's the assumption we start with. And so it's really, really important that I remember that I can only use these equations if I am referring to a situation of constant acceleration. So let's get started. The way we're going to start this is by starting with a velocity time graph. Okay, so I'm going to start deriving my first equation. Now, on this velocity time graph, I want to represent a situation that has constant acceleration. Okay, so I can draw a straight line with a gradient. Okay, and this is a generalized term, so it doesn't necessarily matter what line I draw. Okay, one thing I've done to be able to enable me to generalize is I've made sure that I have some initial velocity. Okay, I have a y-intercept here. That helps me because if I put the line through the origin, although that could potentially be constant acceleration, I'm removing some situations where I may have some other starting velocity. So I'm going to try and be as general as possible here. Now, I've drawn a straight line with a constant gradient because I know the gradient is acceleration. So if the gradient is acceleration and my assumption is the acceleration is constant, then I'm going to have a straight line. Okay, easy as that. Now it makes sense at this point, if I know the gradient is acceleration, I might as well try and find some general way of me finding the acceleration. What is a general term for the acceleration on this velocity time graph? It's going to need me to define a few things, but firstly I know to find it, I'm going to need to find the change in the y over the change in the x. Okay, so change in the y value here, I need to have a sense of what this value is and what this value is. Now, this is in general form, so I can define them myself, and I'm going to define this point v as the final velocity and this point u as the initial velocity. Okay, so at time t equals 0, I've got a velocity of u. At some other time, I've got a velocity of v. Okay, so that means straight away I can say that the top of this fraction, and I'm going to finish this fraction here, it's not complete yet. The top of this fraction, the change in y is v minus u. Okay, v minus u. I then need to find the change in x. Okay, and so I want to define what is my time at the point when I've got a velocity of v, and I'm just going to say that it's t. Okay, so after t seconds, I have a velocity of v, which means that I can finish this equation, this statement of acceleration, that it's v minus u over t. Okay, and this is in general terms, v minus u over t. Now, this is a useful formulation for me. Okay, that's the change in the velocity over time will give me the acceleration. Okay, but what I want to do is get it into a very specific form that the first SUVAT equation is in. So I'm going to multiply both sides by t, and I get this, that at equals v minus u. And because I've got this negative u on this side and it's not an especially satisfying equation, I'm then going to add u to both sides and I get this, that v equals u plus at. Okay? Now that is the SUVAT equation 1. That's my first equation, my first SUVAT equation. So v equals u plus at. And that's a key one to remember. Okay, so we've started by finding the gradient and we found an expression for the acceleration, and then we've managed to rearrange that into our first SUVAT equation. So if we found the gradient, now let's find the displacement, or the area under the curve. Okay, so I know that the displacement S will equal the area under the curve. So it's exactly the same situation. And this time I want to find the area under the curve. Now to do that, I'm going to use the area of a trapezium. Okay, you can break this down into a rectangular triangle if you want to, and if you want to do that on your own and see if you get the same result, you absolutely can. But the area of a trapezium is a plus b, so that's the two parallel sides added together, divided by 2, times by the distance between them. So my parallel sides of this trapezium here are this length and this length, okay, which are u and v. Okay, divide them by 2 and then multiply them by the distance between them. And so I know that if the displacement S is the area under the curve, then S equals U plus V over 2 multiplied by the distance between them, which is T. Okay, that's the second Suvat equation. Easy as that. And if you do use a compound method to find the area under this curve, you will get the same answer. So feel free to try that if you'd like to. One key thing just to note is that the Suvat equations are given to you in the equations booklet. Okay, so you are given a list of the Suvat equations, but you can be asked to derive them from first principles, which is what I've just done. Okay, it's not that common, I'll be honest, but at the same time, I don't want to be in a situation where next year in your exams you're left being asked this question and you haven't practiced it. Okay, so it is worth understanding where these are derived from. So as I said, we're going to do 2 equations today. So those are our first 2 equations. We're now going to start thinking about how we can use them. And I'm going to go through 4 example questions. I've left us our Suvat equations on the screen for us because we'll always be given them, so we can refer to them at any point. That's fine. But this is my first example. I want to calculate the final velocity of a car that accelerates at 2 meters per second squared from an initial velocity of 3 meters per second for 5 seconds. Now, before I even start trying to think about what to do, I want to do 2 things. I'm first going to make sure that I list each of my variables. Now, these are called the Suvat equations because S, U, V, A, and T are the 5 variables that I'll have in my different equations. Okay, so I want to list any ones that I'm given in the question. I also want to draw some diagram that's going to help me understand what's going on, help me visualize what's going on. So I'm going to make a list of the Suvat, okay, S, U, V, A, and T, and I'm going to do this for every single question in which I use Suvat. Okay, I'm just going to write S, U, V, A, and T so I can collect which ones I've got from the question. I also want to draw this situation so I can have a sense of what is going on. Now, before I start drawing it, I need to define a direction as positive. Okay, I know that velocity and acceleration are both vector quantities, and so I need to make sure that I have a direction that is positive labelled. So I'm just going to choose that towards the right is positive. I can change that towards the left if you want to. It's absolutely not a problem. Okay, now because I've chosen that way as positive, I'm also going to say, because I'm not told, that the velocity of the car is moving that way and is therefore positive. Okay. That helps me visualize the situation. I have this car, which I've drawn as a blue rectangle, and it's moving with a velocity of 3 meters per second, and it's accelerating in the same direction. Okay, that's implied by the question, by the signs in the question. Once I've got some representation, and this might seem not that useful, but get into the habit of drawing every single question. You will see, as this is an incredibly easy Suvat question, you will see that these get very difficult. So we're always going to draw a representation every single time. Now, my next thing is I'm going to go through the whole question and collect every bit of information. Okay, it says calculate the final velocity of a car that accelerates at 2 meters per second squared. So I'm going to write that next to A from an initial velocity of 3 meters per second. So that goes next to U, which is initial velocity, for 5 seconds. So my time T is 5 seconds. Now, I also want to just double check what the question is asking me, and it says calculate the final velocity of a car. So I'm going to put a little question mark next to V. By putting that question mark, I know what variable this question is asking me to solve for. Okay. Now, I've only got 2 equations at the moment, but I will have 5 eventually, and I need to get very good at selecting which equation I want to choose. The way I need to do that is by identifying each equation. There are 5 of them. Each equation will have 4 of the 5 variables in it. So the reason I'm going to make sure that I've got some question mark here is I don't have anything next to S. I'm not even being asked about it. So I want the equation that doesn't include S. I want the equation that includes U, V, A, and T. So I'm going to look over here, and that straight away is the first one. U, V, A, and T. Okay, so I'm going to use the first Suvat equation. I'm going to write it down. V equals U plus AT. Now at this point, this is a substitution and solve question that my year 9s could do. Right? Really, really simple. I don't know what V is, so I'm not going to substitute anything for that. U is 3, A is 2, T is 5. Okay, so 3 plus 2 times 5, really easy, 13 meters per second, and that's that first question done. Okay, once I've got that equation sorted. Now, this might seem like lots of preparation for this much kind of this easy maths that is this easy. Sorry, you will see that these get a lot more difficult, and getting into good habits now will mean that you're getting every single question right. So it's absolutely non-negotiable that we're going through this part for every single Suvat question we do. We have to draw a diagram, we have to write Suvat down the side. Okay, let's have a look at example 2. I want to calculate the time taken for a car to accelerate uniformly from 4 meters per second to 16 meters per second over a distance of 30 meters. So, S, U, V, A, and T. I'm writing it again. Again, I'm going to define a direction as positive. Okay, and again, I've got a car, so I'm going to have I've got a car that accelerates uniformly from 4 meters per second to 16 meters per second. Okay. And it says that's over a distance of 30 meters. This is just a diagram that's showing me. I know what the initial, I know what final is. You don't even really need to put these on here. It's just showing us that this is how this car is moving. Okay, that diagram will help us to visualize what's happening. Okay, now clearly I can see straight away. I can deduce some things, not even calculating anything. I can go right. I've got a positive initial velocity of 4, and then a positive final velocity of 16 meters per second. So it must be accelerating. Okay, and the acceleration must be in the same direction as the motion, because the magnitude of my velocity is increasing. Okay, so that makes sense to me. This is an accelerating vehicle. I'm told that in the question, but clearly that makes sense as well with my diagram. Now I'm going to collect what information I've got for my 5 variables. I've got U is 4 meters per second, because it says from 4 meters per second to 16 meters per second, so V is 16 meters per second. And it says over a distance of 30 meters, so my displacement then is 30 meters. Sorry, that should say meters. Okay, that's my mistake, that should say meters. You've got S, U, and V, and I need to just double check what the question's asking me. It says calculate the time taken, okay? And the time is what I'm looking for. Now again, I'm going to revisit my equations. I've got S, U, V, and T are the 4 things that are kind of written next to. So S, U, V, and T. So it's the second equation I'm going to use. Now, I'm going to write that equation down, and then I'm going to substitute and solve. Okay, S is 30, U and V are 4 and 16, and then I need to find T. Now, this one can look a little bit complicated. It's not. Solve the bracket and divide it. Nice and simple. 30 equals 10t, t equals 3 seconds. Easy as that. 2 more examples that are going to get slightly more difficult. Okay, example number 3. A tennis ball is struck and after 5 seconds is travelling at a velocity of 14 meters per second. Given that the ball decelerates uniformly at 4 meters per second squared, calculate the velocity of the ball immediately after it was struck. So, lots of information here again. That's why we always are going to write SUVA. I'm going to define the direction as positive, and then I'm going to start collecting some information. I've got a tennis ball, okay, and it says after 5 seconds. So after 5 seconds, this is the final velocity. After 5 seconds is travelling at a velocity of 14 meters per second. Okay, it says given that the ball decelerates uniformly at 4 meters per second squared, calculate the velocity of the ball immediately after it was struck. So I'm looking for the initial velocity. Okay, I don't know what that is yet, but I want to start collecting my information over here. Okay, and you can do this as you go, as you're building this diagram as well. Tennis ball is struck up, and after 5 seconds, so 5 seconds is the time, is travelling at a velocity of 14 meters per second. So V is 14 meters per second. It says, given that the ball decelerates uniformly at 4 meters per second squared, calculate the velocity of the ball immediately after it was struck. Now, decelerate is a key word here. I've got 4 meters per second squared, but if this is decelerating, that means I need the acceleration to go in the opposite direction to the motion, the opposite direction of the motion. So I've got negative 4 meters per second squared as the acceleration. Okay, my acceleration has to be negative 4 meters per second squared. So that's my deceleration, is a negative value of acceleration. And I want to calculate the velocity of the ball immediately after it was struck. So it's U I want to find. Okay. Now, same thing as normal. I'm going to look, I've got U, V, A, and T that are labelled or noted against. And so I'm going to revisit my, my list over here, and I'm going to go, right, U, V, A, and T is this top one. And so V equals U plus AT. I'm going to substitute. Negative 4 times 5 gives us negative 20, so I'm going to add that to the other side. So U is 34 meters per second. Okay. Now, key thing here, and this is going to make sense, if I have not used a negative value here, then U will be smaller than V, which wouldn't make sense because I'm told the ball decelerates. Okay, so we need to be really, really careful here that this makes sense in the context of the question. One more example, which is definitely the most complicated and comes in 2 parts. Really make sure we're listening here and making any notes as we need. So example 4. A particle starts at 48 meters per second and moves along the x-axis from the origin to point A in 4 seconds. Given that the particle accelerates uniformly at 3 meters per second towards the origin, find the velocity of the ball at point A. We're going to start with that, with part A, okay? But first of all, I'm always going to draw a diagram, okay? I'm going to have a positive direction, and I've got O, A, and B. Now, B comes in the second part. I've popped it in there. Now, if we read the whole question first, we'll see that there's B in the second part, so I've left it in there. We're going to focus on the first part to begin with. I've defined a direction as positive, and I know that the particle starts at 48 meters per second. I definitely need to make sure for part A that I've got suvat written. Okay? I'm going to go through the question and collect all the information. The particle starts at 48 meters per second. Okay, so my initial velocity is 48 meters per second and moves along the x-axis from the origin to point A in 4 seconds. So time is 4 seconds. Given that the particle accelerates uniformly at 3 meters per second squared towards the origin. Now this is difficult here, towards the origin. It's telling me the acceleration points this way towards the origin. Okay? Because the acceleration points towards the origin, and my particle is moving towards A, that means it's going against my direction. So I'm going to have a negative acceleration, negative 3 meters per second. Okay, because the acceleration is pointing towards the origin. It then asks me to find the velocity of the ball at point A, so I want to find V. Again. And we'll get used to using these two equations quite quickly. I'm going to look. I've got V equals U plus AT, and I'm going to write it. I'm going to substitute, and I'm going to solve, and I get V equals 36 meters per second. Now, if you haven't followed exactly that, then please pause the video and do that calculation yourself just to double check it. Once I've got that, I can look at part B. Okay, I'm going to put part B. I'm going to get rid of the information on my diagram or redraw my diagram if I want to, because key thing here. Or potentially I wouldn't get rid of it. I just make sure I'm doing my diagram in pencil, because then I can rub anything out. Okay, but I'm going to then make sure I'm rewriting suvat. The key reason I'm going to rewrite suvat is there's a particular phrase in part B that's implied. Okay, it says part A is particle subject to a new acceleration. The acceleration has changed, and so I need to redo suvat for between A and B, because this only applies for constant acceleration. If the acceleration has changed to a new constant, I need to redo suvat, okay? Recollect my information, re-go through my process. So I'm going to go from here. At point A, the particle is subject to a new acceleration and travels from point A and comes to rest at point B, which is 46 meters away. Find the length of time it takes for the particle to reach B. So, again, I go through all of part B and collect all the information. Subject to a new acceleration travels from point A and comes to rest at point B. Okay, so it comes to rest at point B, that's the far end. So B, where it's V is 0 meters per second at point B. Okay, it says that that's 46 meters away, so my displacement is 46 meters. And it says find the length of time that it takes the particle to reach B. Now here we've got an issue, because I've only got 3 bits of information labelled. So I actually can't tell which one of these two I need to use. If we get to that point, we've missed something in the question. Okay. What I need to remember and what I need to revisit is the fact that we've already worked out what the velocity of the ball is at point A when this new acceleration takes hold. And so my initial velocity will be 36 meters per second, my answer from part A. Okay, so my initial velocity is 36 meters per second. At that point, I've got S, U, V, and T, which is my second equation here. So I'm going to write it, I'm going to substitute, I'm going to solve. Okay, and I get T equals 2.56 seconds. Key things to remember before you have a go at the pre-quiz and then go onto the sheet. Key things. Always make sure that you're listing your variables and making sure that you're writing each of the individual variables next to them. Collect all the information from the question. If the acceleration changes, you rewrite every single one of your variables. Okay? Draw diagrams for every question you get. This question is here primarily to show you how useful a diagram is. Okay? The diagram makes this easy because you can collect information. Draw more than one diagram if you want to. They're there to help you. Okay? Don't be shy with your diagrams. Once you've collected information, selected your equation, it's then plugging in and calculating. That bit should be simple if you do everything else easily. Sorry, you do everything else well. Okay? Go on to the pre-quiz for me, please. Any questions, let us know. And good luck with the work.